In this lesson, we're going to review two topics that you already learned in Algebra 1, but it's been a couple years, so we're going to review how to solve quadratic equations using the completing the square method and using the quadratic formula. To solve a quadratic equation by completing the square, we want to move the constant term to the right side of the equation and leave a blank where it used to be. So we'll have x squared minus 10x equals negative 2. And we're going to leave a blank here and a blank here, which is where we're going to complete the square. So when we say complete the square, what that means is we're going to complete this side of the equation by filling in this blank with a number that makes the left side of the equation into a perfect square. So that's why we're saying we're completing the square. So the way that you complete the square is you look at the coefficient of x, which in this case is negative 10, and you take half of it and square it. So if we take half of negative 10, we get negative 5. Negative 5 squared is 25. So we put plus 25 plus 25, because if I add 25 to the left side of the equation, I need to add 25 to the right side as well. And then by doing that, we have now created a perfect square, which means I should be able to factor this expression and get the same factor twice. So if we factor x squared minus 10x plus 25, we get x minus 5 times x minus 5, which is x minus 5 squared. So as you see, we put a number here that made this into a perfect square. On the right side of the equation, we have 23. And now to get x by itself, we're going to take the square root of both sides. And as we learned in the section 3.1, when we take the square root of both sides, we need to do plus and minus. So that's going to be plus and minus the square root of 23. And then add 5. So x equals 5 plus and minus the square root of 23. We'll go ahead and do example B together as well. So first step, move the 1 to the other side. So I have plus blank, and if I add 1 to both sides, then now I have 1 plus blank. And then to complete the square, again, we look at the coefficient of x, which is 4. Take half of it, which is 2, and square it. That gives us 4. So plus 4 and plus 4. And now when we factor this, that's x plus 2 times x plus 2 equals 5. So we have x plus 2 squared equals 5. Take the square root of both sides, plus and minus. We get x plus 2 equals positive and negative square root of 5. And then we can subtract 2 from both sides. X equals negative 2 plus and minus square root 5. So that gives us our two equations, or two solutions. Negative 2 plus root 5 and negative 2 minus root 5. Okay, so I would like you to go ahead and pause your video and try example C, and we'll show the solution when you're done. Just go ahead and press play when you're ready to see the solution. So if we subtract 10 from both sides, we have x squared plus 2x equals negative 10. And to complete the square, we'll take half of 2, which is 1, and square it, which is 1. So we're going to add 1 to both sides. Now we have x plus 1 squared equals negative 9. And when we take the square root, we get x plus 1 equals plus and minus the square root of negative 9. So we see in this one we're going to get complex solutions. And so then if we subtract 1 from both sides, we get x equals negative 1 plus and minus. The square root of negative 9 is 3i, because the square root of negative 1 is I, and the square root of 9 is 3. So we get negative 1 plus and minus 3i. Okay, go ahead and pause your video again and try example D. For example D, we'll start off by subtracting 13 from both sides. If we take half of -6, that's -3. Square it, we get 9, so add 9 to both sides. Now we have x minus 3 squared equals -4. So when I take the square root of both sides, I get x minus 3 equals positive and negative square root of -4. So x equals 3 plus and minus the square root of -4 is 2i. In all four of those the first four examples that we did, the coefficient of x squared was 1. So if we look up here at example A, we had 1x squared, example B, 1x squared, example C, 1x squared, and example D, 1x squared. It is necessary to have a leading coefficient of 1 before you complete the square. So if there is a different coefficient, we can always make that leading coefficient 1 by dividing both sides of the equation by the current coefficient. So for example, here in E, we have a 2 as our leading coefficient, or the coefficient of x squared. So what we need to do is, before we do anything else, we're going to divide everything by 2. And now we have x squared plus 3x plus 9/2 equals 0. And so we will subtract 3/2 from both sides, subtract 9/2 from both sides. Okay, and now we're ready to complete the square. And so if we take half of 3, that's 3/2. And by the way, I'm going to do this in fractions, even though a lot of people are more comfortable with decimals. When you're completing the square, this is one situation where fractions are actually easier. You'll see why in just a second. So if I take half of 3, that's 3/2, and then I'm going to square that. And so 3/2 squared is just 9/4. If I had done that in decimals, I would have half of 3 would be 1.5, and then I'd have to do 1.5 squared, which you may be able to do that in your head. But if you have to use a calculator, then that's a situation where using fractions is actually easier. So if we just we started with 3, we cut it in half by dividing by 2, and then we square it, and that gives us 9/4. So we add 9/4 to both sides, and now I have x plus 3/2 times x plus 3/2 is the way that would factor, because 3/2 times 3/2 will give us the 9/4 that we're looking for. So that is x plus 3/2 squared equals, on this side I have negative 18/4 plus 9/4, which would be negative 9/4. So when I take the square root of both sides, I get x plus 3/2 equals plus and minus the square root of negative 9/4. And that is x equals negative 3/2. Sorry, this was 9/4, not 4/9. Then we have negative 3/2 plus and minus. This would be 3/2i. The square root of 9 is 3, and the square root of 4 is 2. The square root of -1 is I. And so that's one way to write the answer. You could also write it as x equals negative 3 plus and minus 3i, all divided by 2. That's the same answer, just written a little bit differently. Okay, so please pause your video and try problem F. First step, we need to divide everything by 3. So now we have x squared minus 2x plus 1 equals 0. And you may recognize this is already a perfect square. If you didn't realize that, then you can just go ahead and go through the same process that we did with the previous problems. And that is, take half of negative 2, square it, you get 1. So notice that we're right back where we started. We have x squared minus 2x plus 1 equals 0, which is exactly where we started. That's because this is already a perfect square. It's x minus 1 times x minus 1. So x minus 1 squared equals 0. Take the square root of both sides. You get x minus 1 equals 0, so that means x equals 1. Next, we're going to review using the quadratic formula. Quadratic formula, written here, refers to the constants a, b, and c, and so that comes from the standard form of a quadratic equation is x squared plus bx plus c equals 0. So anytime you have a quadratic equation with 0 on the right side, a is the coefficient of x squared, b is the coefficient of x, and c is the constant, the one with no variable. Okay, so the first step in using the quadratic formula is to identify what a, b, and c are. And so in this problem, a is 1, that's the coefficient of x squared. B is negative 10, so be very careful with negative signs. Make sure that if there is a subtraction sign, make sure that goes in front of the coefficient. And then c is 2. So now that I have a, b, and c written down, I can just plug right into the quadratic formula. X equals, instead of saying negative b, you want to think of this as the opposite of b. So the opposite of b is positive 10, plus and minus the square root of b squared, which is 100, minus 4 times a times c, all divided by 2 times a. So we have 10 plus and minus the square root of 92 over 2. And that is 10 plus and minus the square root of, let's see, that's 4 times 23 is 92. Square root of 4 is 2. So that gives us x equals 10 plus and minus 2 root 23 all over 2. Or in other words, x equals 5 plus and minus root 23. So I divided the 2 into both of these and got 5 plus and minus the square root of 23. Go ahead and pause your video and try example B. So for example B, we have a equals 1, b equals 4, c equals negative 1. So then x is equal to the opposite of b, plus and minus the square root of b squared, minus 4 times a times c, all over 2a. So x equals negative 4 plus and minus the square root of 20 over 2. That's negative 4 plus and minus the square root of 4 root 5 over 2. I wrote it that way because we're looking for a perfect square that goes into 20, which is 4. So now we have x equals negative 4 plus and minus 2 root 5 over 2. Since 2 divides into both of these, we can go ahead and do that and get negative 2 plus and minus root 5. Okay, on the next one we have a equals 1, b equals 2, c equals 10. So we're going to have x equals the opposite of b, plus and minus the square root of b squared, minus 4 times a times c, all over 2a. So that's negative 2 plus and minus negative 36 over 2, square root of negative 36 over 2. And so that's negative 2 plus and minus 6i over 2, which can be simplified as negative 1 plus and minus 3i. So again, I have to divide 2. 2 has to be able to divide into both of those in order to simplify. So those are our two solutions. Now go ahead and pause your video and try example D. For example D, a equals 1, b equals -6, c is 13, and so x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. And so we have 6 plus and minus 36 minus 4 times 13, so that's -16 over 2. So x equals 6 plus and minus 4i over 2, which simplifies to 3 plus and minus 2i. Now go ahead and try examples E and F. For example E, A equals 2, B equals 6, C equals 9. So we have x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c over 2 times a. So we have -6 plus and minus, let's see, this is 8 times 9 is 72, so we have -36 over 4. And so that is -6 plus and minus 6i over 4. In this case, 4 doesn't divide evenly into 6, but all 3 parts are divisible by 2. So if I multiply the top of the fraction and the bottom of the fraction by 1/2, I get -3 plus and minus 3i over 2. So that would be in simplified form. For problem F, we have a equals 3, b equals -6, c equals 3. So x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c over 2 times a. So x equals 6 plus and minus the square root of 0 over 6. We just get 1. So x equals 1. For the last example, we're not asked to solve these equations. We're just asked to tell how many real and non-real solutions each has. And in order to do that, we're going to use what's called the discriminant. The discriminant is a quantity, it's the same quantity that we put under the radical in the quadratic formula. So if you look at the quadratic formula, the discriminant is just this part that goes under the radical. So it's b squared minus 4ac with no radical. And so the discriminant is just b squared minus 4ac. And so when we calculate d, if d is greater than 0, then we get 2 real solutions. If d is less than 0, we get 2 non-real solutions, meaning it's a complex number with an imaginary part. And if the discriminant equals 0, then we get 1 real double root. So that means that root appears twice. For example, if you had x minus 1 squared equals 0, then x equals 1 would be a double root. Okay, so for each of these equations, we're just going to use the discriminant to determine how many real and non-real solutions we have. So in this case, A is 5, B is 6, and C is 4. So the discriminant is b squared minus 4 times A times C. So that's 36 minus 80, which is negative 44. That is negative, so that tells us there are 2 non-real solutions. For example, B, A is 9, B is 30, C is 25, so our discriminant is b squared, which is 30 squared, which is 900, minus 4 times A times C. So that's 900 minus 900, which is 0. So that tells us there is 1 real solution. Now go ahead and try problems C and D. Use the discriminant to describe how many real or non-real solutions each equation has. For C, the discriminant is 2 squared minus 4 times negative 3 times 6. That is 76, which is positive. That tells us there are 2 real solutions. And for part D, the discriminant is 3 squared minus 4 times negative 2 times negative 8. So our discriminant is negative 55, which is negative, so that tells us there are 2 non-real solutions. And that completes our notes for today. Have a great day.